ahead and get started. This is Securing Docker Instances. I know it's the most original title you guys will see all day, but we're going to go ahead and talk a little bit about some of the new technology that's coming out for DevOps teams. The main one is called Docker. So how many people in the audience have used or run across Docker? How many people have actually found a way to make Docker secure? I'm going to put my hand down too, because I haven't found a perfect way to do it yet, but what I have come up with is a bit of a program that we can use to better integrate with the DevOps teams so that we can meet their schedules. So did anybody see Bill Semp talk today? Yeah, so he talked about care and feeding for developers, and as I was going through an exercise with a client of mine, I saw Bill's talk and thought, you know, that's probably not a bad way to look at Docker, is figuring out a way to make this a tool that allows us to integrate better with the DevOps teams. So to give you a little bit of background of who I am to start with, I'm a security solution architect for a company called Nexigen. We're in Newport, Kentucky, about an hour and a half south of here. I work primarily in the solution space and enterprise consulting space. So I work with some of the bigger companies in Cincinnati, working on policies and procedures to help them get a little bit more secure. I also design out the security solutions that we offer internally on an as-a-service basis, or more comprehensive solutions than just putting a firewall in place. I've been a technology enthusiast and security evangelist since 2004. I've got various security and infrastructure industry certifications. I love cigars and coffee as well. As anybody who knows me from Twitter, which I see quite a few of you already know pretty well. So what is Docker? And this is my favorite infographic, I guess we could call it, for describing Docker. And this took me a half an hour to get right, but this is a shipping ships. And yes, that took as much practice as you think it did. Basically, what Docker is none of that. What it is it's kind of the water, right? The shipping ship would probably be the actual host VM, and the shipping ships would be the containers that the applications are contained within. So Docker really is, as 451 Research says, is a tool that can package an application and its dependencies in a virtual container that can run on any Linux server. This helps enable flexibility and portability on where the application can run, whether on-prem, public cloud, private cloud, bare metal, whatever. Right? So everybody knows that already. I saw a lot of hands saying they've run across Docker. But what Docker really is a containerized application for allowing DevOps teams to ship code more effectively. Right? So why is this more effective than the traditional shipping code to multiple VMs? Well, what it allows is collaboration and communication from dev to QA to production, because we're maintaining one code set and across that entire deployment. So when dev builds it, they ship that same container to the QA, and then that container gets shipped right to production. And then when that one is replaced, that gets destroyed and another container rolls into its place. So basically, what we're doing is, instead of deploying to multiple VMs, multiple environments, multiple different platforms that all have their own footprint, we're sharing that. We're sharing containers. We're saying, here's where the container is, here's where it lies in the life cycle, and this is what I need done with it right now. It allows the containers to be deployed and destroyed with really, really quick, incredible quickness and a lot of flexibility, because there's no separate OS build, there's no re-imaging of servers. It's a click and you can ship type application. Docker was released as an open source platform almost 3 years ago, March of 2013. Version 0.9 added the libcontainer library, which allowed direct access. So basically what libcontainer did is, instead of using a bunch of different APIs to get to the virtualization technologies that are inherent in the kernel, basically KVM for that matter, libcontainer basically allowed direct access to KVM features like the network stack and some of the other features that are inherent in the operating system. that are now kind of moving up into the container, as you'll see in 1.10 and a few of the newer versions. Red Hat, IBM, Google, Cisco are all very large contributors, and the current drive for Docker is to be operating system independent. So they want to be not just Linux anymore. They want to run on pretty much anything at some point in the near future. Whether or not that actually happens is going to be dependent on a lot of other things outside of the control of the Docker project. But right now, that is their overall goal, is to be able to ship from a Linux environment to a Windows environment without the application needing to be recompiled, recoded, rebuilt, anything. That's, from what it looks like, a very long ways off. What isn't Docker? Right? So I hear it compared a lot to virtualization technologies, but it isn't. Right? It's not, there's no VM. Right? So you don't have some of the footprint of a VM that you would have with a technology like KVM or like VMware. It's not built to be inherently secure. The jails that are put in place on the Docker kernel are not like what you would get out of a VM. It's not a virtual sandbox. It does behave similarly to a virtual sandbox, but it is rather easy to break out of. Okay? And it is not a panacea for application hosting. You have to be very mature in your processes and in your security processes to be ready for Docker. That's one of the things we'll talk about, is whether or not are you actually ready for the Docker platform. Is this something that your application development has reached a level of where you have the security built into your application to allow it to be ready? So here's a bit of a diagram of Docker, right? And so what we saw is libvirt, LXC, and systemd nspawn were kind of where we were integrating with the virtualization kernels, or the virtualization features of the kernel for a long time. What libcontainer has done is really allowed direct access to that. So we don't have to use those, although we can still use the APIs built in to interface with the base OS. But it uses things like AppArmor, netlinks, cgroups, and namespaces, although not user namespaces yet, which we'll get into a little bit. But has anybody looked at the namespaces and how it actually integrates with the base OS? No? Okay. That's probably the biggest issue with Docker security right now is namespaces. But to go back a little bit, a container can span multiple physical hosts, which is another thing that it does very well compared to a virtualization technology. You can use resources on multiple hosts and assign a container an application to run in quite a few different places. You can put limits on resources based on a per container basis. So I can say this container gets this amount of RAM, this amount of CPU. Disk utilization is one of the funny things right now. If you're not running on a SAN, and you can't really control your disk utilization from that kind of throttling, it can be a little bit hairy, right? You can have quite a bit of contention based on running multiple containers on the same host if you have that kind of architecture. If you don't, then you're probably going to be okay. Each container does have network interfaces, process IDs, and file system structures. So each container really has all of the prerequisites to run as a separate application. The namespaces feature does provide good isolation from other containers. That's very important to note, that it's only other containers that namespaces gives you isolation from, because basically each process runs in its own namespace. Because those processes run in their own namespace, it's very difficult to cross between containers. However, it's not that difficult to cross from the container to the host and then back from the host into another container. So this is a big security vulnerability that will be patched very soon here. But we do have some security benefits to it. Each version of the application runs in a container. All containers have a separate network stack, right? Containers only contains application-specific dependencies, which means that each container doesn't necessarily have to meet an exact baseline configuration for your organization, and it minimizes the security footprint based on things that you may not need per application. So your base build for Red Hat includes OpenSSL, but this application doesn't use OpenSSL. We don't have to have that service running. We limit our footprint per application. Like I said earlier, the container is then shipped from dev to QA and then to production, meaning that the container itself, not the code within the container, but the container itself, can be audited once, right? This is a security benefit for us, is that I can look at a container once and say, okay, this container is good to be shipped, and it's good to be shipped for a certain amount of time. All right, I can put expiration dates on these and say, you are allowed to use this container at will until X date, 90 days from now, 120 days from now, and you can tailor this to what your dev schedule is, so that you can work with them to say, here's your agility based on the platform, and I'm going to approve this for 90 days, right? Or I'm going to approve this for 120 days. And when you ship code, I'm going to have a new container ready for you when you're ready to ship your next release. Another security benefit is the kernel level controls are in use. So namespaces gives the different file system and stack. Containers only require the dependencies, and control groups allocate resources, preventing one container from DOSing the entire host or cluster, right? So we really have good containerization of those. Sure.
Just FYI, they just showed the first car. If you did park in any place that says the word patient in that spot, you might want to go and move the car right now. Just a heads up. I have no idea. Other than they said that they gave us plenty of warning, so just FYI. Thank you, sir.
No problem. So back to, the kernel level controls are in place. However, there are some security concerns based around that. Because it's a shared kernel architecture, it wasn't designed for security, right? Because we've got that interaction between the container and the kernel, it's not terribly difficult to break out of the container if you have access at an SSH level or any kind of level beyond a web application that's deployed in it. Okay, so if you've got people FTPing into a server, or into an application, it really doesn't belong in Docker. Any kind of command level access is probably not a good idea. A root user in the container is also a root user on the host, which is where we get into namespaces, right? Because we don't have user namespaces right now, which is shipping supposedly in February. It's out of its experimental release in Fedora. It's shipping with Docker starting in 1.10. But as of right now, a root user in the container is also a root user on the host, which makes it very, very difficult to contain a user in one application, or contain a user within the container itself. The Docker daemon itself runs as root, right? So we have a potential privilege escalation issue there, and a potential lateral movement issue as well if you don't have very good controls on your root passwords and your access controls. It's not difficult to escape that sandbox. Now, with the user namespaces coming very soon, that's going to get significantly better. And we were doing a study. This all came from a study that I did for a client on how to better integrate their new Agile methodology with their security processes. They were very limited on their security resources, and they were hoping that this could help reduce the footprint of their current KVM environment to a manageable level, right? And because of the root privileges for the daemon and the root privileges in the containers, that became a significant problem for them. And there was a question in the back. Did you have a question? Oh, I thought I saw you raise your hand. Sorry. It depends on what the dependencies are, right? So if you require, you can, but you'd have a very hard time doing any kind of remediation on the container without actually, you wouldn't be able to upgrade anything in the container itself, which gets into more than 30% of the containers in the Docker Hub contain serious security vulnerabilities. So there's this Docker hub, and Docker hub is basically a place where you can go grab containers, right? Pre-built containers. It's like an app store, right? And more than 30% of them, because one of the powerful things about Docker is you can ship things and then you can destroy them very quickly, but it's very difficult to know what you've put out there. And nobody was really keeping an eye on the hub to make sure that things that had been patched were rebuilt. Those containers stayed out there for quite a long time, and you could download a container that was still had vulnerable to Heartbleed and Poodle and all the other nasties that we had in 2014 and 15. There was a very little oversight over that Docker hub, which meant that a lot of containers were getting shipped with vulnerabilities that nobody really saw. And a lot of the time, these were being shipped in some of the cloud platforms like AWS, where security teams didn't have a lot of oversight as to what was being shipped, and caused some pretty significant issues. Now, there's a push for cleanup of that stuff, but auditing your containers is really a very important thing to do. There's also, again, because of that, there's potential for multiple instances of an application. Yeah. So it's possible. There's some dependencies that still require root privileges to run, and if you can engineer around those dependencies, then you can get away with running without a root user. But you still got the Docker daemon running as root, which integrates between the two, and that's not something that's been fixed. So the other issue you can have here is there's a potential for two instances of the same application at different patch levels to be running, because you're not updating a server anymore. You're actually shipping a new container. So if you don't destroy the container that was in place before you ship a new one, it's very, very easy to leave old code revisions with vulnerabilities still in place shipped to a production environment without really any kind of oversight as to what is being audited, because the container's been shipped, right? Security is only keeping an eye on the new stuff. It's not keeping an eye on that shadow IT environment that's unfortunately still there. So that's the communication aspect of Docker is very important to make sure that once you've shipped code, that you destroy the old instance. It's tough for a lot of dev teams, and I mentioned earlier about having to be ready for Docker. One of the things that's very difficult is because you're shipping a brand new build every single time, you cannot rely on relics, right? A lot of code still relies on older relics. And you can break a lot of things if you're not ready for that kind of dev cycle, where you are rebuilding and reattaching everything every single time brand new. So I've seen, again, where dev processes weren't mature enough for Docker, it causing some problems in the proof of concept side. So we'll talk a little bit about user namespaces now. The experimental version was released in 1.9. It's scheduled for 1.10 next month. There's been some significant improvements in the 1.10 build. That means that you no longer have to migrate some of your prerequisites to a new folder within the host, which were causing a lot of things to break. 1.10 should be a relatively easy upgrade to do on your hosts now. And it will provide user namespaces, which gives a lot more segmentation between your container environment and your host environment. Sorry, word escaped me for a second there. It basically, what this does is maps a root GUID in the container to a non-root GUID outside the container. That will be a very, very big improvement in what we're actually able to do with Docker from a security standpoint of segmenting the two environments to a much more in-depth level. And that's basically what I just said there. So looking at the vulnerabilities a little bit here, the all images that you see there, 962, higher medium priority vulnerabilities in all the images were over 64%. And the high priority was over 36%. Yep. Mm-hmm. The main benefit of the next release, from what I understand, is going to be the namespaces feature, but I'm not sure on the network stack changes. I would have to look into that for you and get back with you. If you shoot me an email, I'll make sure to get with you on that one. I was looking primarily for the user namespaces because, from a security perspective, that's really kind of what I'm driving towards here, as opposed to the more infrastructure side of it. Back to the created in 2015, there were 675 images. 74% of them contained medium or high vulnerabilities, high priority vulnerabilities. So back to that vulnerability management talk earlier today. If you're not auditing your containers before you ship them, and you're trusting what's in the Docker hub, you probably got a pretty big issue there. Even with 47% of the latest containers being shipped with vulnerabilities in the high or medium priority category. So kind of, now that I've got through what Docker really is, okay, the core of what we're going to discuss is discover, analyze, deploy, and audit regularly. Figuring out, how do I add security to this dev process, right? How do I integrate with the dev team to allow them the flexibility to work more with security instead of having that adversarial relationship that we typically have a tendency to have, right? So if I look at this, I can actually take the containers and look at them as release dates, right? And I can integrate myself into an agile environment or a waterfall environment based on allowing myself to be integrated into their release process, right? So when we're talking about AppSec instead of a typical, I've got infrastructure security and I want you guys to fix your security, I can integrate these containers into a process that will allow us to work together. The first one, discover, is really, am I ready for Docker, right? Are my development processes mature enough to be ready to ship code on a regular basis and to meet the deadlines that I put in place for containers to be destroyed, right? If I'm going to allow them to ship containers that I've pre-approved, are they going to be able to make the deadlines that we put in place to have those containers expire when they're supposed to expire? What are my fallback options if Docker fails, right? Where do I go? Am I going to put in this infrastructure and then have it blow up? How am I going to fall back to an old version of the application? What are my fallback options? And then testing the Docker containers to work with the applications without root privileges is very important. That gets back to what we were talking about earlier, is if I can get my containers to run without root privileges, I'm going to have a much more successful Docker implementation. Now that's, again, significantly changing here, but it's always better to get these containers running without root privileges, right? It's always going to be better to have my dependencies running in a space that's protected. So if I can get my applications running without root privileges, I'm going to be better off. And decide whether the apps are ready. Are the new versions shipped through defined processes, right? Am I shipping code on processes, or am I shipping stuff on an irregular basis where I'm going to have issues that come up with deploying containers and destroying them on schedule? And then the relics, eliminating all the relics that may cause issues, right? Making sure that I have a containerized application before I use a containerized deployment technology. Does that make sense to everybody? Yeah. Any other questions before I move on to the analyze phase? No? Okay. Then analyze. What's going to be in the Docker instance, right? How secure are the jails that I have in place? How secure is my code that's in there? Okay. Will the application require SSH, FTP, or any type of terminal access to the server? Am I deploying an application that's going to give a potential for privilege escalation, right? Or am I deploying an application that's just a web app, right? and I can ship code, and people are only ever going to hit a web interface. And that's a good portion of what Docker is built around enabling. And will an existing audited container satisfy requirements? This is where we integrate better with the dev teams, is I can provide an audited container pre-approved from the security department to say this is good through December of this year, or now it's January. This is good through March of this year, right? You can ship containers until March of this year, or you can ship applications on this container pre-approved until March of this year. And now I don't have to focus on that unless a major vulnerability comes out, or I can focus on the AppSec side of it. I don't have to be auditing that container on a regular basis. Having the audited containers is really, really important, and auditing those containers is also as important in how you actually do it. Having a tool like Linus, the enterprise suite of Linus has a Docker auditing feature that's there that you can purchase in their enterprise version that will actually audit your Docker instances and your Docker configuration to tell you whether or not you're meeting best practices, right? Did anybody ever use Bastille on Linux back a while ago? Yeah? See a couple. Linus is kind of an evolution of Bastille. I've used it quite a bit when I was working in the banking industry to audit SCO Unix and a few other boxes that I had running Red Hat, and it basically gives you a command line. Linus goes as far as to help you remediate as well through automated scripts. My advice to you is be very, very careful with that, because the automated stuff can break things very badly to the point where you will be redeploying that server. But it will give you a baseline, and if you know how to remediate based off that baseline, you will have a pretty solid container after that. Which basically gets to the setting standards, right? Decide on a set of standards, right? What are my acceptable containers in the marketplace, okay? If somebody needs to grab something, be proactive towards saying, hey, there's a new container out there. I'm going to go ahead and pre-audit it and allow my dev team to download it if they need it, right? If we have the time and we have the resources available, if I'm embracing Docker, I can start embracing these containers and auditing them ahead of time to make sure that when I deploy it, I'm actually going to be secure. Define the standard OS builds for the hosts, right? What are my hosts going to have? Because the hosts still have a footprint, right? It may not be big, but there's still an OS underneath Docker, and there's still a footprint there that we have to protect and that we have to think about. So defining a standard OS build, in regulated industries, you have a baseline configuration policy, right? And developing a baseline configuration for my Docker hosts is going to be as important as defining a baseline configuration for my switches and my firewalls and everything else. Define versions of dependencies, and I knocked a few off of here because a few of them have kind of died off recently, but what versions of the dependencies am I okay with, right? What versions of OpenSSL? What versions of crypto am I allowed to use? Pre-approving those things and saying these are good or these have known vulnerabilities will simplify the process of when I fire up a container and I look at what's running inside of it, I know that it either meets my baseline or exceeds my baseline or falls short of my baseline. So defining these standards is critical for agility when you're actually looking at these containers. And then audit the standards regularly. This is pretty common stuff, but auditing them regularly and maintaining an active standards knowledge base, right? So if I have a security department of more than one person, I want to maintain a knowledge base that says, okay, this vulnerability came out for this version of OpenSSL, right? This is no longer an accepted version, and having that in a place where people can get to it and people can actually interact and work together on securing the baselines. And then, again, adopt the best practices. Yep. Did you have a question? Yep. Oh, sorry. Audit with a tool like Linus. And then audit the containers as well. So audit your base builds on a regular basis. audit your containers as well, and you can do those both with Linus. Implementing continuous controls, right? We want to audit the containers for best practices before they hit prod, right? So if I say this container is okay, I want to verify that the code that's been deployed to it before it ships prod is also okay. So I want to implement some kind of code analysis before it goes to prod to make sure that even though the container is okay, that I'm taking a look at what's inside the container now before it ships out to the internet. Perform regular penetration tests, right? That should be pretty standard for everybody here. Regular pen tests are gonna give you a lot better results. Implement a vulnerability scanner like Ness's. Make sure that you're being proactive towards vulnerability scanning. Again, because these containers are very easy to leave in place on accident, and the oversight over what containers are in production are difficult to notice. So a vulnerability scanner is going to open up the security's eyes to say, hey, why is this still vulnerable? Oh, that's a container that we can destroy, right? So if I'm scanning actively on a regular basis and I'm discovering things that should have been replaced or destroyed, I've got to check. I've got to check and balance with the dev team to say, all right, I got a vulnerable application that's out there. Is this an old container, or do we need to work on patching a new container, right? And then do static code analysis with a focus on privilege escalation, okay? The privilege escalation part is very, very important. If you look at the code and you think about what part of the code might allow an active attacker to escalate his privileges outside the container, that's a very important thing to do. Now, again, when Bill was talking earlier today, he was talking about finding those 15 things that are really important, right? Well, with Docker, one of those 15 things that's really important is finding privilege escalation issues and finding those gotchas that might creep up and bite you at some point. So looking at the code on a regular basis is very, very important. I've got some references here for you guys. The user namespaces, that's actually changed recently. The analyzing the Docker Hub, the second one is one of the is where we got the statistics for the vulnerable Docker instances, and then the last one is a kind of a guide to how to ship code in Docker. My contact info, if you're a Twitter person, is LinkState. And you can also email me, cjh@nexigen.com. I'd be happy to answer any questions afterwards, and I do have some time for Q&A. I actually have quite a bit of time. I got through this pretty quick today, so I usually have a lot more interaction between slides here. So does anybody have questions that I didn't answer as we went through it? Yep.
Yeah, so you mentioned OpenSSL.
Yeah.
So if I have a Docker instance that uses one version of OpenSSL, and then a new set of applications that uses a different version for whatever reason, I guess are those separate versions running at the same time?
Yeah. So each container will have its own version running. So that would be looked at as a dependency. So that would be contained within the container itself, as opposed to running on the host. So yeah, you could have multiple versions running of those dependencies at any given time. That's one of the things to be very careful of, is knowing what's running on your network, and that's where the vulnerability management comes into place. It's a very powerful tool for shipping things on a really, really tight schedule. I've seen companies that are doing two week sprints in the Agile process, that it was difficult for them to deploy the application to 3 sets of servers in 2 weeks, right? So they were looking at Docker as a way for them to interact without having to reship everything every single time, right? And that was a challenge for them that they weren't ready for because of some of their root privilege issues, and their enterprise service bus wasn't necessarily ready for the Docker side because of some relic issues that they had. So there's some significant challenges around that type of technology. Anybody else? I know I caught you guys after lunch here, so it's not exactly the opportune time for having a talk. So, thanks everybody.